After all, there was a moment in human history called the Dark Ages when matter and energy were there but knowledge and light were absent. In sharp contrast, the internet has made it possible for us to document every facet of our life in this day and age. Every detail is readily logged and uploaded to the internet, where it will always be available to future generations. They will get the exceptional chance to learn personally about our experiences. However, as we are now living in the present, it is not easy to learn about the past. We frequently discover that reconstructing historical tales requires us to devote endless hours to investigation. However, by making this effort, we can learn things that could influence our future. Unexpected surprises have been revealed by the interesting chemical data that researchers have recently started getting from diverse surfaces in space. Through this corpus of work, researchers have pinpointed areas in which entire galaxies have disappeared and been replaced by completely new formations. This finding changes our understanding of the universe and has significant ramifications. Come along as we investigate the secrets of these vanishing galaxies and consider the implications of their disappearance for our future. The Greater Unconformity is one particularly intriguing mystery that has baffled experts for decades in the field of geology. This occurrence marks a major void in the Earth's geological record, extending from 100 million to 1 billion years, during which there is almost no geological activity. During this period, Earth's geological clock seemed to have stopped abruptly. It is unnerving to consider that millions of years were lost over this long, unrecorded time, and we have no idea what happened or how Earth recovered. While most geological riddles are solved by ideas, there is plenty of evidence to support its existence in this case. Globally, the Greater Unconformity has been observed in a number of rock formations with localized manifestations. In certain cases, it is just a brief moment in time, but in others, it takes place across long stretches of time. It continues to be one of the biggest nonconformities ever found. Interestingly, the Greater Unconformity is not only a question of missing rocks. Very little remains of the geological formations that were present during this time due to erosion. The rocks that are still present from this era clearly show evidence of weathering and erosion, indicating that they have been exposed to the elements for an extended period of time. This makes us wonder what happened at this mysterious period in Earth's history. According to a widely accepted view, the planet experienced intense weathering and erosion, which essentially destroyed any pre-existing rock formations. Another idea contends that these rocks were destroyed and new formations were created as a result of a significant tectonic event. There is geological evidence to support the idea that Earth has previously undergone other major tectonic events. In a similar vein, the universe functions behind a curtain of mystery. Similar to Earth's Greater Unconformity, the cosmos is home to the Great Void, an enormous void that beyond human understanding. Galaxies, stars, and even dark matter are almost entirely absent from this region. It begs the questions, what caused so many galaxies to vanish? And is this a phenomenon that could be occurring elsewhere in the universe? Scientists have been fascinated by the mysterious phenomenon known as the Great Void for a long time. It's an uncommon and fascinating subject to explore because of its sheer size and emptiness. This vast region, which is a part of the Adani supervoid, is predicted to cover around 1 billion light-years. The void itself is thought to cover approximately 300 million light-years, making it one of the largest known voids. Although it's not empty entirely, it's far less crowded than the places around it. Many theories have been put out by researchers in their quest to comprehend the origins of the Great Void. One theory is that early black holes, which originated in the early stages of the universe, may have consumed nearby matter and left behind a massive void. It's possible that the minuscule quantum disturbances that gave rise to these black holes developed as the cosmos expanded. There is evidence that black holes are consuming large amounts of space, which begs the question, could they have gathered enough mass to engulf entire galaxies? A different idea suggests that cosmic strings, which are hypothetically thin and extremely dense structures that developed in the early cosmos, may have reacted with gravity and the surrounding matter to push matter away and create vast empty spaces like the Great Void. According to this scenario, the space formed by this matter displacement can be explained without the need for dark matter or other cosmic components. The Great Void may just be a manifestation of cosmic variance, a phenomena in which the universe shows large-scale non-uniformity. According to yet another interpretation, certain sections of the universe are inherently less inhabited than others, just as some areas of a photograph may appear more busy than others. Perhaps the Great Void is just one instance of this cosmic diversity. But what if we have all along miscalculated the structure of the universe? Astronomer Edwin Hubble first postulated the idea of an expanding universe at the beginning of the 20th century, based on the observation that galaxies travel farther away from us at a faster speed. This resulted in the astonishing discovery announced in the late 1990s that the universe was not only expanding, but growing faster than before. Supernovae, or burst stars, were observed to be the source of an unexplained acceleration known as dark energy. One of the biggest puzzles in current cosmology is still the nature of dark energy. Galaxies will someday recede to such distances that they will appear to be traveling away from us faster than the speed of light as the universe accelerates and continues to expand. This implies that we might not only be unable to travel to these galaxies, but also be unable to watch them as their light dims and eventually vanishes from our field of view. There is an enormous variety of galaxies, stars, planets, and other celestial objects in the cosmos that we live in. Amazingly, the cosmic microwave background, CMB, the oldest light in the universe, is still visible today. This radiation is a byproduct of the Big Bang, which occurred about 14 billion years ago and gave rise to our universe. It was first identified in the 1960s by radio astronomers Arno Penzias and Robert Wilson. Everything, including time and space, was formed by this enormous explosion, of which the CMB is the afterglow. It was hot and dense at first, but once the cosmos expanded, it cooled down enough for the first atoms to form about 380,000 years after the Big Bang. Light may now move freely across space and eventually materialize as the CMB that we see today. With its ability to capture the universe at a remarkably young age of only 380,000 years, the CMB offers priceless insights into the early state of the universe. Through the examination of temperature fluctuations in the CMB, researchers have acquired vital insights into the early cosmos. Small quantum density fluctuations caused these discrepancies, which were further magnified by cosmic inflation, the universe's incredibly fast expansion after the Big Bang. The cosmic microwave background, CMB, has shed light on numerous features of the early cosmos, but it has also revealed oddities, such as the CMB cold spot, which is a noticeably colder area inside the CMB. This cold region is far larger than the typical oscillations reported in the primordial CMB, spanning about 5 degrees in radius and around 70 microkelvin lower than the average CMB temperature. A number of theories, from statistical abnormalities to the existence of supervoids or even exotic physics like parallel worlds, have been proposed to explain this frigid area. Furthermore, the enigma surrounding dark matter persists in testing our comprehension of the cosmos. The mysterious material that makes up the majority of the universe, known as dark matter, is essential to the development of galaxies. It has been discovered that certain dwarf galaxies have significantly less dark matter than previously thought. 19 dwarf galaxies that differ from our expectations regarding the distribution of dark matter have been found by researchers. Because of their smaller size and weaker gravity, dwarf galaxies are traditionally predicted to contain significant amounts of dark matter. This is because dark matter is often concentrated in larger quantities than normal matter. These anomalies, however, cast doubt on this theory. Astrophysicists like Kyle Oman have been studying the formation process of these dwarf galaxies and the factors that contributed to their low dark matter content. In 2016, Oman and colleagues discovered 2 galaxies that seemed to be devoid of dark matter, and then they found 2 more. Thus far, 19 dwarf galaxies have been identified. All of them are located within 500 million light-years of Earth. The remaining galaxies are isolated, so it's unclear whether they formed differently or were impacted by events like star explosions, which might have upset their equilibrium of dark and normal matter. In certain cases, scientists hypothesize that nearby galaxies may have taken off their dark matter. Astrophysicist James Bullock of the University of California, Irvine suggests that these dwarf galaxies might not be missing dark matter at all, but rather that they have either kept or perhaps added more normal matter. This finding highlights the variability in galaxy formation and forces scientists to reevaluate current galaxy evolution theories. Our understanding of the cosmos, including our own Milky Way galaxy, depends on our ability to comprehend dark matter and its role in galaxy formation. The terrifying possibility of galaxies vanishing forces us to think about ways in which we could keep them from happening in our galaxy. Even while there might not be a direct threat, we nevertheless need to work hard to comprehend and safeguard our cosmic home. Please leave your comments below if you have any thoughts on these developments. Please give this video a thumbs up and subscribe to our channel in order to see more interesting videos like this one. We're excited to see you once more.